Hello, hope you guys can hear me. Let me just set up few things. I'm going to be doing something different. So I have done a coding stream before, but I want to do more like a learning stream because I want to learn C and get good at it. First, let me just set up my chat. So I'm going to be reading a book. It's in the Creative Commons domain, and I'm basically going to be practicing the C code. But my laptop is really slow. Also, I have to show you something. Let me change to full screen. So this is the C book. After the stream ends, I will just write it in the comment or description. It's called An Introduction to C and GUI Programming. It is in Creative Commons. Yeah, CC by Creative Commons by non-commercial and share alike. And contents. Let me do 2 pages. This is Adobe extension for Opera. Yeah. Let me just zoom in a little bit. I don't know if you guys can see. And hold on. Let me view my own stream. Hold on. I'm just checking whether it's actually visible on stream. My own stream. And hold on. Let me view my own stream. Okay. Maybe I will zoom in a little bit, I guess. Should I like extend this? Yeah, this is a restream. Is there a way to do like transparent appearances? Maybe a background. Let's do 50. How does that look like? Do I have to save? Guess it's okay. And I can still see my message. Okay, let's see. How do I get rid of this? So getting started, learn how to. This book is, I think this book is specifically made for Raspberry Pi. I guess it's okay. Learn how to use C to program the Raspberry Pi. Okay. What's so great about C? Should I do one page? Nah. C is very versatile and widely. C is a very versatile and widely used programming language. It has been used to write pretty much everything from low-level routines to control the hardware in embedded microcontrollers to compete operating systems. Yeah. Many of the languages here we may have seen, such as Python, are what are called interpreted languages. This means that the code you write is run directly. Each line of code is read and interpreted as you run it. C is different. It is a compiled language. This means that the code you write, known as the source code, is never run directly. The source code is passed through a program called a compiler, which converts it into a machine-readable version called an executable or a binary. You then run the resulting executable. This may seem complex, but it has a few advantages. First, it means that you don't need to have a copy of C itself on every computer you might want to run your program on. Once compiled, the executable is standalone and self-contained. Second, the compilation process will find a lot of errors before you even run the program, but it usually won't find all of them. Most importantly, the compilation process means that the time-consuming translation of human-readable code into machine-readable instructions has already passed, which means that compiled code generally runs many times faster than interpreted code would. Okay. Oops. Okay, shift scroll on the side. So first program. So what I would do is run the program. This is something else. So in this default C folder, I would do first .c and I would run the program here. Let me just extend this. What is this? Install. Also for restream, I will have it always on top. Also, I have a website. It's a work in progress. It's basically a study notes website. So this is the website. Anytime I study anything, just write it over here. For example, language learning, mathematics, natural science. And these are more private stuff because it has some copyrighted material. And wait, and one of those things is of course C programming language. So what I would be learning here, would write it in my notes. And so wait, uh, is there a way I can have my avatar on top? Wait, I'm using VMagick Mirror. Okay. So basically, I'm using React, but it's not like with a framework. It's like I'm using Create React app, and I would write the content over here. So basics, 50% here, 50% over there. So it's these two. So going back to the first thing, with all that out of the way, which has hopefully made you think that C might be worth learning, let's have a look at the first program everyone writes in any language. And just copy and paste this. So include studio and then printf. Don't you need to do return null? I guess. Terminal. So this is known as a hash include. As mentioned above, the C language has a large library of functions that can be included, and we need to use one of them in this program. The formatted print command, printf. This is part of the standard input-output library, okay, or stdio for short. So what this line does is to warn the compiler that the program needs stdio library, standard input output library, to be included as part of the compile process. Okay, I think I will do this hello world, and then I'll write it here. And then this is, instead of UL, I have a React component called sublist, and I also have this. So all the code will be written in the code pre-component. Let's see. And write all this, or I'll just write it here. Also, it's a pre, so it's pre-formatted. So if I save this, React should do it automatically, but let's just see. Before I go, yeah, void main. C is a function-based language. Every program is made up of a number of functions. Each function takes 0 or more argument and returns a single value. Function definition consists of a specification of what the function returns, in this case a void. A function name, in this case main, and a list of arguments enclosed in round brackets, again a void. Okay. Every C program has to include a function called main. When you return the compiled program, the main function is the first thing that executes. Okay. The void is called, the first void is called a type specifier. I think both voids would be type specifier. Void is a special type, which means no value required. We will look at more types in the next chapter. So this line defines the main function for this program. It states that the main function takes no argument and returns no value. The code which makes up the function itself is enclosed between two curly brackets that follows the function definition. This is a comment, and this is printf. I don't think I need to read that. Compiling your program. Do I have GCC? Default C. And just do CD. CD. No practice stuff. And I think GCC. Output is okay. Let's forget output for a second. First dot C. You know what is this? No, I think this is an error. I thought this was an int and then we do return 0. Never mind. My laptop is really slow. So is this loaded? Oh, it's loading. Yeah. Hello world. And then language C. Include main printf device. Need to do this. Maybe with the R prefix. Never mind. And not return null. So I'll copy this. And then Control C, Control Shift. Oops. Not Control C. Alt C? Yeah. I have a shortcut Alt C, which puts it in the code element. I'll do this here as well. Alt C, and then formatted. This is part of the standard input output library. Or STDO for short. I copy this. And so it has to include the main. Copy this. Alt C. Okay. Think I'll write my notes as if someone has already programmed before using other languages. Let me see what the end result looks like. I need to split that point somehow. Want to split the is known as a hash. I know what to do. Here, this, then printed is a part. These, okay. Why is there a gap here? This line seems to have a gap. Maybe it just looks that way. I think it just looks that way. Okay, I guess I'm satisfied with this. Compiling a program, let's see what it compiled. So a.exe, let's run a. It should say hello world. But it's so slow. I don't know why this is happening. Kill terminal. Reveal in file explorer. CMD. Let's see if it works here. Yeah. I don't know why the terminal was causing problem. Let's make note in this as well. Come on. Also, you see there's a source color 64. So I have large list of sources. And the 64th one is this. So it's getting the 64th source. And what I can do is I can do like this. It's a custom attribute. Data source 64. And then save. So let me wait for it to reload. Now go here. In the terminal, type, can do code break. So if I want a pure black screen, I can just do this. Then I can do a GCC or my proc. See. Say the hello world program is written in forest.c. Should I write hello? 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 So it will create an executable output file called myprog. Uh, and typing myprog in the terminal will say hello world. Yeah, this is like a fully black screen. So if you don't mention the language, there's a fully black screen. Hello world. And what else? Also, I can do my own explanation. So I have class name on explanation. If the output name is not mentioned, then the executable will be called a.txt. Next one, variables. And arithmetic. So in some languages, you can create variables as you go along and put whatever data you want into them. Wait, yeah, C isn't like that. To use a variable in C, you need to have created it first, and at the time you create it, you have to set what type of value it's going to store. By doing this, a block of memory of correct size can be allocated by the compiler to hold the variable. This process of creating a variable is known as declaration. So I'll just copy this. by doing the above. Should I do a table? Sorry, wait. Types in C. To view other types, you can check the Wikipedia page. See data types. Also, when I added a data source 64, it tells, it means that the element is from the 64th source, which means if I hover, then it says source, an introduction to C and GUI programming, basically this. Uh, the most common one. Should I do code or bold? The most common type is the int type. Should I do code or should I do bold? Type is let's go here. What is this arrangement? So void main int a int b c a and then okay, right. GCC first.c. The top 3 lines are declaration. Okay. The second line we see an example of initialization at the same time as a declaration. Yes, I'll do this. Why is it in what's with the blue line? Initialization. Maybe that's the one with the Z is the US spelling. Note that the values A and C at this point are undefined. Undefined. Alt C. You might assume that a variable which hasn't stored a value in it is always 0. But this isn't the case with C. Before reading the value from a variable or using it in calculation, you must store a value in it. Reading a variable before initializing it is a common error in C. The next two lines do some actual work with the variables we have declared. This stores a value of 2 in the variable A, which will now have this value until it's changed. The reason A is called a variable because it can vary. This line adds A and B. It stores the result in C. Okay. This is another use of the formatted print function we saw in the previous chapter. Note the three symbols %d inside the string. These are format specifiers, and they are how you output numbers in C. When the printf function is executed, each %d is replaced by a decimal representation, d for decimal integer, of the variable in the corresponding position in the list after the string. So first %d will be replaced by the value of A, the second with the value of B, the third with the value of C. I'll just copy this. C, B. How do I access that? A. Can I? No. Hold on. Why is it going to that side? I don't like the opacity thing. Also, I will remove always on top. Okay. And then, yeah. Okay. Think percentage D. Floating point numbers. I should put them in a sublist maybe. Wouldn't it make sense if decimal was used for floating point because it's decimal? So D is used for integer. That's like sure. All of these do the same thing. And their format specifier. Floating point numbers. So we can add two integers together. What else can we do? One thing we might want to do is to use a floating point, is to use floating point numbers. Number with a decimal point. You see, this should be called decimal, and then the other one should be called integer. These have a different type called float. Try changing the code above. So instead of int a, it's float a. This tells the compiler that a is now a floating point value rather than an integer. That doesn't wait. What happens? Float GCC Sum of 0 and 3 is 5. What has happened is that while the math is still all correct, the printf statement is now wrong. You're telling it to print a, which is a floating point value, as a decimal integer. To fix that, the first %d in the printf function, change the first %d in the printf function to %f. Okay. All right. Let's add some notes. To represent a variable like a, as a floating point, use the float type C. Do it. I don't like this. Del printf to use a floating point instead of a float type instead of a instead of a decimal integer. I'll just write this. %f is the format specifier for floating points. It will do exactly what you tell it to, even if it makes no sense. When working with variables, always keep track of what values you're putting in what types. It's easy to introduce errors by assuming a variable is of one type and is actually another. A common error is to put the results of a calculation on floating point values into an integer. Try this. Make b a float as well, not forgetting to change its format specifier in printf, and leave c as int. Set the two floats to values with decimal points like this. You will see a result like 6. That's not right, but it's exactly what you have asked for. What the compiler did was add two floating point values together and got the answer 6.538. But you then told the compiler to put that into C, an integer variable. So the compiler just threw away everything after the decimal point. If you want to change C to a float, change the final %d to %f. If you change C to a float and change the d to f, it gives the correct answer. Okay, wait. Uh, both A and B are floats. Mm, non-integer floats. And what happens if, oops, and C is still an integer? I will put this here. One, two, three, 2.123, 641, 879, 641, 879. It's 897. 897 and 641. So let me actually see if it does. Would give whoops. What is this? Oh, it's like that. This is because since C is an integer, the compiler threw everything after the decimal point. I think I'll add this after here. Okay, I'll also add this. You can set the number of decimal places to display for a floating point type specifier in printf by putting a decimal place and the number of places between the percentage and f. So character value uh, the jar type stores a single character. The ASCII character encoding uses a single value between 0 and 127 for each letter, number, and punctuation symbol. Is a single byte. It's really just an integer value which can hold small numbers. The compiler allocates several bytes to store an int or a float, but only allocates a single byte of memory to store a character. There are also modifiers which can be applied to variable types. Both char and int can be used to store both positive and negative numbers, but by applying unsigned modifiers, when one is declared, they can be restricted to only store positive values. So char a declares a variable which can hold values from minus 128 to 127, while unsigned char a declares a variable which can hold values from 0 to 255. When doing arithmetic with chars, it is important to make sure that the answer to any calculation will fit into the variable. If, say, you have a character containing the value 100 and you add 30 to it, you would expect to end up with the result 130. But as above, a character can only hold values up to 127. So the value your char will actually end up containing is minus 126. Because values over 127 wrap around the lowest value and start counting up from there. The overflow behavior is a common cause of bugs in C programs which do arithmetic. Okay. I'll write this. So char a declares a variable char b declares a variable. Okay. I need to press C hard. Yeah, have a char containing 100 at 30. The value your char actually end up containing is minus 126. C obeys common rules for operators. Okay. That gives you some idea about how C handles numbers, and you can use it for arithmetic. In the next chapter, we will look how to use the results of calculation to make decisions, conditions, and compare. Okay, let me just see this character. Right. I think I will do this last chapter and then I will end the stream. Conditions and comparisons. I'll do this, do it like this, not this, copy properly. Okay, so why does it do that? printf a if this, then this, else this. See, I don't like space between parentheses and the function. And copy this, paste it here. The keyword if is enclosed in round brackets. In this case, a is equal to 0 if the test evaluates as true. The operation enclosed by the curly brackets after the test are executed. The mechanism for controlling flow based on testing a condition is the if-else statement. I'll just do this. This control tab or alt tab, yeah. Why doesn't this work? Copy text. Is the if-else statement and at the end of the curly brackets around the operations which you want to execute, if the test is true, there is also an else followed by another set of curly brackets. Okay, I will just type this. There is also an else. Copy text. So single equal versus double equal. equals sign is used for two different things. One is to assign a value to a variable, whereas the other is to test whether a variable is equal to true. Okay. Or copy. So we do this, 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 less than, it's greater than. There we go. Looping. The if statement is useful for making a single decision, but what if you want to do something repeatedly until a test is true or false? You'll use the while loop. For example, just write it here. The while loop. I have finished. Hold on. What is this? So yeah, I'll just copy this. A is equal to this. A is equal to this. And I've finished. the if the condition you test in a while loop never evaluates to false, program will sit in the loop forever and never finish. It's not copying properly. Now it is. Sometimes you might want a loop which always runs at least once before a test is made. Copy this. Can use the do while loop here. Do this printf do this. Yeah. Hmm. What about the for loop? I think I should just end it here. Study the for loop later. What is this? Should I put while in bold? Okay, let me see if this works and then I will end the stream. Why is this? Does everything else work correctly? Okay. Yeah, I will end the stream here. Okay, this works. This works. Wait, the elect doesn't work. Do I have to write HTTPS? TTPS like that maybe. Copy, paste. Okay, then let's see if this works. Okay, guess I will end the stream here. Then and then I don't know. Then I think maybe tonight or tomorrow I'll do another stream. Probably learning a language or be learning C because I really want to get good at C. Okay, and see you next time, I guess.